percent, how it becomes dot over H1?
Here's a nice thing. How many, do we all agree, how many places does a decimal have to move between percentage and decimals?
Two?
Twice, because percent means per hundred, right? It's just a question of which way to move this stupid thing, right?
Yeah.
Here's something kind of cool. Decimal percent, put it down in alphabetical order. If I want to go from a decimal to a percentage, I move the decimal that way. If I want to go from a percent to a decimal, move it that way. So 8.5%, I got to move it twice. Which way? That way. Do you guys see what I'm saying? I mean, that's kind of a cool little, if you have any trouble with that, you got to start with knowing you got to move it twice. It's just which way do I go? Percent, it's already percent, I want to go to a decimal, so I got to move it that way.
You want to go to the hundredth place, correct?
Yeah.
Well, basically, because
You want the
five is
8,
already there.
you want the
Five is
8 and the hundreds place.
If it is the opposite from
So if I had 0.003 is what percent?
That's 3%.
That's a decimal to a percentage. I have to move the decimal place that way.
So you go 3%.
Careful. How many times do I move it?
0.3.
0.3%. Right? Well, some of you guys are just like. But I'm hoping some of you guys realize, I mean, that's kind of, just put it in alphabetical order and it tells you which way to move the damn thing. You got to start knowing you got to move it twice. Or at least now you know which way to move it. And to finish this out, you divide by 1.085. What is it now?
860.
850?
60.
60.
Excuse me, for the angles, I like, because this is the first semester I am taking math, so I don't know the expressions like complementary. It's
Oh,
like,
and they explain it like,
860, right?
here, page 119. The way I remember it is, who knows two complementary angles? What do they do? When
like
you add them
both of
together, it
them.
makes
180.
a 90.
Oh, no.
So the way I remember it is alphabetical order. C goes to 90, complementary is 90,
Yeah.
supplementary 180.
Oh.
So I just remember that, you know, C comes before S and 90 before 180. So let's try one. Let's try
I solved it for both of them.
number
For
17.
90 and 180.
So there's number 17 on page 126. This says two supplementary angles are such that one is 8 times larger than the other. So I want to make a point here. This is going to seem, wow, just going to make this point. Use exactly the same words the word problem does, even when it's something kind of weird like this. What are my two players here? There's two players.
Angles,
2 angles.
What are their names that they tell me in English?
supplementary. One is 8 times and one is more than the
No,
other.
that's bringing math in. I just want names. One, so I got one angle,
What is an angle? Larger.
is 8 times larger than the other. So I've got the other angle.
The other angle is x, and then the first angle is x.
Beautiful. So the one angle is 8 times this guy. I love it. Since this guy is some function of this guy, I've got to know this guy first. Right?
So x.
So the one angle, if I call him x,
Right.
the one is 8 times this.
That's gonna be 8x.
8x. I love it.
Equals 180.
I love it. There's two supplementary angles add up to be 180. They make a straight line. I can't. Oh, straight. There you go. Right. So I got this angle added to this angle has to give me
180.
180. If they would have said complementary, it would have added to be 90.
So you divide 8 into 180.
No.
No, it's 9x.
Oh, 9
Divide by
into
9.
180.
You always divide last.
Okay.
So I got my like terms split together.
Equals
20.
180, and it's gonna be 90.
Divide by 9. Careful.
20.
20. So don't stop there, right? How many answers should you give me?
Yeah.
2 answers.
So up here you got 20 what? 20 bananas? 20
Degrees.
degrees?
And 8 times 180.
8 times 20 is?
160.
And how do you know you're right? How do you?
Add them up.
Add
180.
Because they actually do what they're supposed to do, right? They add it to be 180. I love it. Cool. 2x minus 3y. So this is actually page 112, number 42, this one. Now this should seem familiar to most of you guys. When we get to graphing, we'll be doing a lot of this because I want to solve for y, so I put it in the right form for a line. Right now, all I want to do is solve for y.
Oh, okay, negative 2x.
Beautiful, right? So remember, whenever you have an equation that's got more than one variable in it, and you're trying to solve for one of them, find the term that has your variable in it, and get that term by itself. So I want to get rid of this guy.
Yeah.
So like you said, subtract 2x. So I get
Is a negative 3y equals 6 plus negative 2x.
Cool.
Y equals mx plus b.
And then divide everything
That's
by
exactly
negative
Then you would.
Yeah, exactly. Now just divide by negative
Multiply
3.
3.
Yeah.
And you could either do, just put it underneath everything, or you could put it underneath each one.
Yeah.
But for right now, you're done.
Do you do
right?
it by a negative 3 or positive 3?
Again,
It's negative 3. Because if
I
you
think the
divide-
thing that some of us kind of mix up is
Yes.
I don't change the sign. I do the opposite operation.
Yeah.
So here this is plus 2x, so I subtracted 2x. I didn't change the sign, I just the opposite operation. This is a negative 3 times y. I got to divide by negative 3. I got to do the opposite of multiplication, not the opposite of negative.
Yeah.
I divide by what the number is. And so you can either say it's this, right, and that's fine, or you could break it up.
Okay.
Either way, so you can stop there, or you can go further and say it's that. Either one.
I can't stop to this one.
Sure, you can stop there for right now. Which one's better for lines?
Can you
The first
simplify
one.
that?
Careful.
Second one.
The
Bottom
second
one.
Because now it's mx plus b.
Yeah.
Right, then I can see each piece, right? So when we get to the graphing part, we're definitely going to want to go further and break it up. So I can see the slope and I can see the y-intercept.
Okay.
Yeah,
I don't know what you did.
in the same section. Was it?
I lost it.
Uh-oh.
I lost it. I did get the 2.
Are you okay here?
Yeah?
Beautiful. So then what did I do next? I did 6 divided by negative 3
Okay.
minus 2x divided by negative 3. Because what's being divided by negative 3?
2.
The 6
Okay, so.
and the 2x.
So I can cancel there, right?
Beautiful, yeah.
That's what I'm saying. You get a 2 on top.
Yeah, so here you get a negative 2 because it's divided by negative.
Right.
Negative and negative makes plus 2/3 x. Right. So you can stop there or there for right now. Doesn't matter.
Because you can't do nothing with that side at all.
Yeah. So here you're done. Here that's fine because it's not a line yet. Later it will be.
They're both right.
They're both right. Yeah. That's why you got to hear on the back of the book. You're going to have one way, and it might be the same thing you got, just in a different format. Yeah. Let's see. 54.
What chapter? What
Same page, right? Yeah. This is page 112. Now, here, there's a couple different ways to do this, but if you want to, you can always kill your fractions if you have an equation, right? So if you want to, you can make it kind of, you always do that. So if I did want to kill my fractions here, what would I do? Yeah, what is the LCD?
16.
And then what would I do with that?
Multiply by.
Yeah, multiply each piece by 16. Is that cool? I mean, that's, since it's an equation, I saw some of you guys on the homework, it wasn't an equation, but you somehow magically made the fractions disappear. Why am I allowed to do that here? Because I got two sides that will balance. But you only have one side, there's no balancing. I can't kill my denominator set, right? And again, that would be like, I wanted to write down, so if I found two 50-cent pieces, I have $2. Because 1/2 plus 1/2, oh, multiply by 2, 1 plus 1 is 2, I got $2. Now, What? That's David Copperfieldish, right? Or is that name too old? Who's it? No magicians
I
nowadays?
remember.
Oh, well, too bad. That's magic, how's that? So what do I get here, 16 and 16?
X,
So I get X,
8, negative 8y.
beautiful. So that minus, I'm gonna go ahead and pull it up there and make it more explicit there. Minus 8y.
16.
And now you're trying to solve for y probably, right?
Yeah.
Yeah. So now you can just go ahead and solve for y. So you guys might realize that if you just subtract x over 16, you only have one more thing to do to solve for y. So some of you guys might do this problem a different way. But right here, this should be pretty straightforward to try to solve for y, right?
Yeah.
Subtract the x, divide by negative 8.
Okay, that's what confuses me. Do you add an 8 and then move it over to that side?
You could, but then you're moving stuff more than once. But I mean, it doesn't really matter. If I do add 8y, if I do add
No, I didn't
8y,
mean 8y, just 8.
Oh.
Solving for y, right?
Yeah, I'm just gonna move.
true, but that would be fine. But instead, what do I want to move?
Yeah,
X over the,
So I want to move the x over, and then divide by negative 8. Yeah. But if you don't like negative numbers, you could have added the 8y, because then it'll be positive. It's a little more work, but still. There's more flexibility in math than you think, especially when you get higher up. Math is not always black and white. There's a lot of gray areas in math, right? But for us, it's kind of black and white. You got to get that answer, but there's a lot of different ways to get to it. So you can stop there, or you can break it up like we did over there.
negative 2 minus x.
Careful.
Oh, yeah.
Got to break them both up over 8, right?
I can the answer y. 60 minus x over.
Yeah. So you can stop here,
Yeah.
or you could break them up, right? And this, of course, is negative 2. The negatives cancel, 1/8 x. So if you stop there, that's great. If you stop there,
Do you need to make it 1/8 x, or could you just put x?
it could stay x over 8, sure. And I'm doing that because now I can see like my slope, and that's going to become important later, of course.
Would you suggest to write it that way?
I would. Just a suggestion for right now, but later it's become a necessity.
Number 17.
Okay. Oh, here we go. This is might be what you're talking about. Oh no, wait. 8 is 2% of what number, right?
8 is 2% of what number?
Now, I gotta tell you, this problem seems really small. It's got this huge history of all this weird shit. It's just all these different ways. Is over of, that's the one that most people know. I gotta tell you, that's harder than it has to be. I've seen these weird things where people have A is of, and you cover it, and oh my god, that is crap. That is pure crap. This is English that goes directly into mathish. 8 is equals 2%,
0.2.
0.02, right? Of means
Times.
times
Blind.
what number? I don't know.
X.
X.
There you go, see? None of the other crap required, right? That is a total direct translation from English to the foreign language of math. Right? And not all you gotta do is do what to get x by itself.
8 over 0.02.
You want to get rid of 0.02, so you gotta divide by 0.02, right?
Can you put that in proportion?
You could, yeah. So if you wanted to, 8 is, so it's 2% of one number, so is over of equals percent over 100, right? So you have 8 is, the percentage is 2, of what? Sure. But do you see how that's, I mean, if that's what you're used to, feel free. But you see how that's so much more than you really, really need? I mean, bingo. Then